Okay, well, we're going to start session number 3 now, going through chapters 5, 6, and 7. You'll be happy to know it was after going through these couple of chapters and thinking about what I was going to cover that led me to the decision that we're not going to be doing tests in this class. There's too much to cover. I'm going to have you basically show competence in doing these assignments. So we're going to ixnay on the test. I know that'll be heartbreaking to most of you, but I wanted to share with you, going back to our agenda here, Chapter 5, a little story at the start of things. When I was at college at The Ohio State University, I took a physics test in one semester, and I got a score of 45 out of 100, and I was ecstatic. I took a psychology test the same semester. I got a score of 80 and was very upset out of 100. The question I have for you is, how could that have actually been? How could I get a score of 45 and be happy and get a score of 80 and not be so happy? Well, the answer to this, and if you've taken physics before, you'll certainly appreciate this. The answer to this equation is very simple. Although a 45 is a terrible non-passing score, relative to the group, I was actually brilliant because the mean of the group, the mu of the group, was 40 there. On the psychology test, a score of 80 is not so bad, but the mean for that test was a 90. And so if you really want to figure out how somebody did on the test, it's not an absolute situation in most situations, but it's basically how smart or stupid are you relative to the group. I'm sure you've all been in this situation before, and so the way that we actually go about doing this maps very well into the discussion in Chapter 5. It has to do with z-scores, and in B, I put the z-score formula. The basic way you can figure out how you did relative to other people is you have to know what your score was, you have to know what the mean was, and then you have to know a measure of dispersion. And the most frequent measure of dispersion we use is the standard deviation. And so the idea is you can get a z-score computation here. And I think in this chapter, let's see, do they give the formula in here? Looks like on page 142, and in B, put the z-score formula, x minus mu over sigma. And so the idea is, if you take my physics test situation, my score was a 45, the mean was a 40, and the standard deviation was a 5. So can you figure out what the z-score is for that? Hopefully you came up with a value of +1. So on my physics test, I got a score of +1. On my psychology test, hopefully you came up with the idea that I got a score of 80, the mean was 90, and the standard D was 10. I got a z-score of -1. And so the z-score formula lets you take an individual score, compare it to the group, and say how you did relative to the group. So we can get a z-score of one situation +1, the other situation -1. The next thing I need you to do is turn to page 699 of your book, because it actually tells us some things about z-scores and about distributions. Now, what if I told you I got a z-score of 0? Would that be good news or bad news, a z-score of 0? Well, if I told you I got a z-score of 0 on the physics test, what would have been my score? It would have been a 40, right? Because the class average is 40 and my score is a 40, so the z-score, 40 minus 40 is 0. If you get a z-score of 0, what that actually tells you is down in C on page 699. If you get a z-score of 0, that means that half of the class did better than you and half the class did worse. If you look at that picture and you look on the top of the chart there, it says z of 0. That means the B proportion, half did better and half did worse. So a z-score of 0 means you did average. So hopefully that makes sense. Let's look at a z-score of 1. If you go on page 699, actually it would be page 700 on a z-score formula chart, and you look in the second column, if you get a z-score of 1, that means you basically did the proportion in the body, which is 50%, for the z-score of 0, then another 34% going up to a z-score of 1. That means that you did better than 84% of the group, and 16% did better than you. So you would actually use the z-score formula and see that. I'm sorry I didn't make a visual of that, but that would be the way of it. And then if you get a z-score of 2 on something, that means if you go to that spot, that you did better than 97% of the group, and only 2% did better than you. So the z-score formula is a way, and if you want to read in the book some more about this, figuring out where you did relative to the group. So if you get a z-score of 0, you did average. A z-score of -1 would mean that you did worse than 84% of the class and only better than 16%. A z-score of -2 would mean you did worse than 97% of the class and only better than 3%. So the idea is the higher you are on the z-score, the better off you are. So if you want to read some information in Chapter 5 about that, that was kind of my testing and learning point with that. And I'm going to have you do a problem on 162. It's problem 22. It says you got a z-score or a score of x of 56 and a mu of 50. The standard deviation was 4. And then on another test, you got a score of 60. The mean was 50 and the sigma was 20. The question is, which one did you do better on? You got to get your z-score for each one of those. And the higher your z-score is, that's the one you did better on. So see if you can do that and show some competency on that. And that'll be the Chapter 5 information. Thanks, everyone. Bye-bye.